Let's see. Testing. All right, can my online students hear me okay? Check. Online students, can you hear me okay? Yes, all right, perfect. Then let us go ahead and get started. So we are currently in the module for week 2 and 3. We're talking about functions. We're going to finish up the PowerPoint, and then what I'd like to do is go over. I have a couple of files that we can go over to try to understand a little more about functions. But before we do that, I want to try an exercise out together. So while we're finishing up the lecture, if you all have your laptops with you, for those of us that have them, and if you have JGrasp installed, go ahead and get that open. And we're going to use that today and possibly Wednesday for the exercise that we're going to work on. You all can work together. So if you don't have one, please sit with someone that does, so you all can kind of work together through it. But let's go ahead and get started. So we were talking about, we were in the second half of the functions lecture, right? We were talking about defining our own functions. How do we make our own functions? All right, let's just quickly review the different parts of a function. So you have this data type here. When you're defining a function, all functions return something or nothing. What do we put right here if a function doesn't return anything? What word goes right here if a function doesn't return anything at all? Void, very good. Then a function has a name. I have to have something some way to call that function to tell it I want to execute these instructions. And then optionally, a function may need information, right? So we kept giving the example of adding two numbers together, right? And what's the information I need? I need to know what those two numbers are. You have to give those two numbers to me so I can add them together. So these are called parameters or input arguments. And as part of your function definition, you would just provide a comma-separated list of variable declarations, right? The data type that you need, followed by something to put it in, some variable name that you can use inside your function. And finally, the last piece of the function are your instructions. Here's what I want you to do. So we looked at some examples, how to write functions that have parameters and return things and that don't. And then we moved on to section 2. So question number 1, this is a question for you all. And hopefully you all can infer this answer. Do you think you can call a function from within another function? So if I'm writing a function, can I call a function inside of there? I have some no's, I have some yeses. So one of my yeses, tell me why. How do you know that? What makes you make that guess? Yes. Exactly. We've already been doing that. Main is a function, right? Remember, that is the first function that the computer calls. And what have we been doing this whole time? We've been using printf. We've been using other things. We've been calling other functions from main. So you can definitely call a function from within another function. And where do you write your function? Well, it turns out there are a couple of places you can write them. Any file with a .c extension. So .c, it's really just a text file. So let me give you an example. We'll take a look at that later. Let's say I made this new file and I have, some stuff in here, some stuff. Let's save this on my desktop. And we can see that my file name is, we'll call it new2. So if I go to my desktop, you can see I have a file now called new2.txt. That's all a C file is. It's just a text file, except I'm going to go in here and I'm going to right click it. And I'm going to change the txt to a C. Now it's a C file, right? It's still a text file, really, but the C tells my computer that you can open this with any program that knows how to read C files, but it's just a text file. So Where can you write your functions? Well, anything with a .c extension, you can put functions in there. Functions, just like variables, have to be declared before you can use them. What does that mean? Well, we've already seen examples where we can of importing functions and using functions that other people wrote. We already know how to do that. But if we were to write our own function, I should have done this earlier. And one of the files we're going to go, one of the files we are going to go over later will demonstrate that. But just so you can see it really quickly before we move on. Here we go. Let's here we go. So include page. So here, let's suppose I wanted to write this function. We'll take the simple function we've been doing, add 2. So I can add 2 numbers together, num1, number 2, and all I'm going to do is just return number 1 plus number 2. Very simple function. If I wanted to use that, you'll see if I tried to use that here, I'm actually going to get an error. Let me try to compile this and let's see what the message says. Implicit declaration of function add 2. And what happens is when the computer attempts to compile this, when the compiler attempts to convert this code to machine instruction, it's going to get to line 5 and it's going to say, okay, you want to do this, but I don't know what that is. I haven't seen the definition for that yet. I don't know what add 2 is. It's the same as doing something like this, x equals 22, but then down here, I do in x, right? You can't use the variable x before you say it exists, right? So before I can do this, I have to declare that variable, right? Say, hey, there's a variable called x and it exists. Now I can do line 7. Well, the same thing applies here. Before I can use this function, I have to either define it or say that it exists. And there's 2 ways to do that. Number 1, I could copy it and just move it up here. All right, so now it's been defined. So if I do it this way, then by the time I get to line 10, the computer has read this definition already. It knows what add 2 means because I just told it what it meant. Or we could create what's called a function prototype, and that's the equivalent to a variable declaration. I could take this line here, this first line, and paste it, and now I'm going to use a semicolon. So be careful with this. This is one mistake I'll see students do often, is they'll attempt to define a function and they'll put a semicolon there. What does that semicolon mean? What does that semicolon mean in C? End of instruction. So if I'm trying to define a function and I put a semicolon there, what's going to happen to this stuff? It's going to ignore it because this is the end of my instruction. Now, in this case, that's what I want to do. All I'm saying is, hey, computer, and line 7, I'm going to tell you to use add 2. I know I haven't defined it yet, but I promise you it exists. Here it is. Here's my prototype, right? Here's the name, here's what it returns, and here are the 2 parameters. And this is acceptable if I do it that way as well. So you notice if I compile it, now it also doesn't complain, right? Because this is the equivalent to doing int x. So this is the equivalent to my int x. And then of course, this part here is the equivalent to saying x equals some value, right? Prototyping, you can also, and the functions don't have to be in the same file. So here I've defined my functions in the same file. If I wanted to, I could put my function in a different file. Now, this is important because for the rest of the semester, when you do homework, you will never make modifications to the main.c file again. You did it for the first homework. It was really simple. I just wanted you to print something. But for the rest of the semester, that's not the way you're going to write C. You're going to actually put your stuff in a different file. So if we just think about the way this works, and for example, a print statement, that function is written in a different file somewhere. And how did I tell the computer I wanted to use it with this include statement? At the same time, you could write a function in a different file, and you would tell the computer to use your file like this, myfile.c or myfile.h. Right, so this is how you would instruct the computer to use yours: include, and then quotation marks, and the name of your file that you want to use. We won't cover that just yet today. We'll save that for another day because I want time to go over the exercise. But I do want you to be aware that you can write functions in different files. Your program doesn't have to be written just in one file. You can write it in many different files. And finally, a function is ultimately viewed as the data type that it returns, at least when it comes to expressions, right? So you've seen examples where maybe I have an expression or something that requires a parameter that's a certain data type. And there are three ways you can give it to it. You can give it a literal value. What is a literal value? In C, what is a literal value? It's anything that's not saved in a variable. It's literally just the value. Very good. Or you can give it a variable, or you can use a function that returns the data type that's required. So that's what we mean by that last piece right there. Variable scope. We'll go back to this. So I want to go through the example today. We'll come back to variable scope in that last slide later. Let's get to the example so we can start doing a little bit of work in C. So in Canvas, if you go to this week's module, you'll see something called exercise functions. Now, I've already posted a key. Please don't look at it. Remember, this is for your benefit. There's no grade for this. This is just to help us get some practice and learn how to do the stuff that we're talking about now. If you get stuck and you just absolutely can't figure out, then take a look at the key and use it as a way to kind of push you over the edge. But I encourage you to refrain from it if you can. Let's go. So here's what we're going to do. I've given you something called an algorithm, or something like an algorithm. An algorithm in general is simply a step-by-step set of instructions. So a lot of people compare it to a cooking recipe. You know, if you want to learn how to bake a cake, hey, step 1, crack some eggs. Step 2, mix them together. Step 3. So a lot of people make that comparison, but an algorithm is just a step-by-step guide of instructions of how you can do a specific task. Now, for us, this algorithm is going to tell us how to write a specific computer program. And all we want to do, it's a very straightforward problem that we're trying to solve here. I want to write a computer program that can prompt someone for the current time. So what time is it right now? And then I want that person to be able to tell me how far to advance the time. So it's 5 o'clock and you want me to advance 2.5 hours. I want my program to do that and then tell you what the new time would be. If you want me to advance 50 hours, I want you to advance 50 hours and then tell me what the new time would be. That's it. Very simple. And I'm going to kind of help you a little bit in that I'm giving you the algorithm. So I'm giving the instructions and telling you how to do it. And I want us to just try to implement it. Just let us just try to do it. So we're actually not going to start writing function. We're just going to try to do everything in the main for now. And then later we'll try to break up some of these tasks apart and put them in a function. But for now, here's what we need to do. So if we take a look at our algorithm, and I skipped some stuff for the sake of time, we can see here, step 1, what should we do? Well, define the following variables that are all capable of storing whole numbers. So I have some variable names here, so make some variable names, and then ask the user what time it is. How do you think we would do that in our computer program? What's the only way we really know how to do that right now? What function can we use to do that? Well, scanf to get the input, but if I want to tell you something, how do I give you information? Printf, that's right. I need to display something so you can see it and you know what you need to do. So ask the user what time it is, and then you're going to save their response. For the time being, save it as two separate variables. It's easier that way for us anyway. So you can save one whole number in the hour variable and save one whole number in the minute variable. And then of course you'll have to do the same thing for how far they want to advance. How far do you want to move forward? I want to move forward, 2.5 hours. Save them separately. And then let's go ahead and calculate that new time and display it. And here's all the math for that, how you would do that. So that is the first exercise I'd like us to do. So feel free, you can ask any questions you want. Go ahead and get started. Again, if you don't have JGrasp on your computers, please sit with someone that does, work together, and let's try to get a little bit of practice writing C. And I will be here to answer your questions. We'll have them later, but for now, just like we said earlier, the variable has to exist before you use them. You're going to use them down here. Before you use them, you need to say that they exist. So that's all we're doing right now. And they should all be in it. Now you have some place you can put all your data back file. Now you have to make it file. This is kind of like a separate folder. For every time that you want to say, oh, so why don't I kind of do a little bit of it on the board so everyone can kind of see and we can all be on the same page. I know some of us haven't used JGrasp yet. So let's start completely over. So let's say I just opened my JGrasp and I want to make my first C program. What do I do? So first of all, just in case you all weren't aware, remember in Canvas, we do have right here in general information / help. There's some stuff on using JGrasp and there's videos and stuff too. With that being said, what do we do first? Well, ideally, so we don't have stuff scattered all over the place. It'd be nice if we had one folder for all of our C projects or all of our C code. So why don't we start by doing that? I'll just go on my computer. Well, I can't do it here. I'm in Linux. So you can see here are my folders. We'll do it this way. So this is what my this is what my Windows Explorer looks like. Let's put it that way, right? In Linux. So let's say I wanted to make, that's not very helpful. Do this, that's still a lot. So you notice I already have a folder made here. This is, JGrasp projects. That's where I put my stuff at. So let's say on your computer, however you make it, typically you're going to go here in your File Explorer, and then maybe you go to your documents and you make some kind of folder there. Then I would go into JGrasp and I'd select that folder. So here, we're going to find that folder I just made. So there's my username. And I have this, remember we pointed out the JGrasp projects, and I'm going to put all my JGrasp stuff in here. Now it's time to make, I want to make this file. So why don't we separate it even more? And for each, let's say, homework assignment or exercise, maybe I have it in a different folder. So they're all separate. It's easy for me to find stuff. We can go here to project, make a new project, not Java. We'll say other. And this will just be, let's call it exercise 1. No spaces. Linux does not like spaces. And we're using, if you're using Cygwin, you're using Linux. It's emulating Linux, so no spaces. I'm going to check this box, create new directory. A directory is a fancy word for folder. So make a new folder. And then I'm just going to next. So now, if you look in your Project Explorer, your File Explorer, you can see I have a folder here called exercise 1. So let's go to exercise 1. It should be empty. Now I can make a new C file. So here we have a C file. And we can start editing this. So let's, what's one thing we know we're need? I know we're going to need to print stuff. So we'll include standard input output library. So standard io.h. I know at least I need that much. And of course, we need a main method, right? We have to have one. So let's just write a generic main method. We'll write int main void so we don't stop warning us. And this is where we want to get started right here. Oops. I click the save button. So I'm going to call my file, anything. I'll just call it, we'll call it exercise1.c. Now, file names have the same rules that variable names do. So you can use letters and numbers and underscore, but it has to start with a letter or an underscore. So exercise 1, no spaces. And we can start by, let's make a couple of variables, right? So we had int, what was it? All right, so an int, and we'll just make a current hour. We'll start with that one, current hour. All right, so int current hour. So now we've gotten, can everyone see what's on the board? right? So now we should know how to make a new project, make a new C file, and at least start with a skeleton of a C program, right? So I've got my statement here to include some other functions I want to use. I've got my main method here, and everything is just going to go inside the main method for now. So all of the instructions that we have seen, they are all just going to go inside that main method. Let me put this back up. Don't do that. All right, I have this as a Word doc. Let me just open that up.
Just wanted to ask why when you compile Node.js, or maybe this is with C++ in general, why you need line after your last bracket or your bracelet. Like for example, if you were to compile that, I assume it would need an error. You would need to have a line 8. And I'm asking why that is when you compile.
So that is a question that would normally get answered in a compiler class.
Okay.
So it has to do with the way the compiler parses the file. It's probably a little more advanced than we would want to cover in this class. But what it is when you're looking for things in the file, some program, remember we said this is just words, right? It's your characters in a text file. And some program has to try to understand what this means. So it'll scan and say, hey, what's int? Oh, that means this data type. What's main? Oh, that means this, that means this. And when it gets to the end, depending on how they wrote the compiler and what kind of regular expression they're using to match things, sometimes it's easier if you have one new line at the end. I know to look for that return key and say, okay, this now I'm done. It makes it a little bit easier to distinguish that from the end of file. So some parsers, older parsers were written that way. Now it's not so much necessary. Most of the newer ones don't give you that a message anymore.
Yes, sir. Also, when you're initializing a lot of variables, would you most often do them all in one, or would you have a preference depending on what you're doing specifically, or like in terms of your organizational skills, would you just like throw them all into one massive INT, or?
So stuff like that, regardless of how you do it, it's going to be pretty fast on the computer. So ideally for us, when you're writing this is for you. So you want to write it in a way that makes sense to you. And if I wanted to, I can show you, you can write a C program that works, that looks like this. You actually don't need many spaces, and you don't need line breaks. But this starts to get really hard to read. So if you wanted to, you could write your whole program on one line like this, and the computer could care less. I mean, it's going to do those instructions. It'll understand it, and if I run it, you see it can execute that instruction. But for a human being, that's really hard to read, right? So we want to organize it in a way that's easy for us to read and work with. later, we will talk about some techniques for making the code a little more efficient. But that's usually not one of them. For the most part, our goal right now is to make sure, maybe as important or more important for now, is make sure we can understand what the code's supposed to be doing. Well, so what we see on the screen, this is what we want to do, right? So these are things I want. Now, if you think about it, think about what you're creating, and you're creating a computer program. So from, given that context, the context of this computer program, how would you ask someone something? Yeah, you're writing a computer program. This is the only way, this is your interaction with someone else. In this case, it's going to be with yourself. How would you ask somebody something if this is the way you have to interact with us? You print it, that's right. Very good. So if that's how you printing that will display that question to you and you'll see it and you'll understand that that's some statement. But now I want to be able to interact with the program. That's right. So how would you, what function would you use? That's right, scanf. That's when you would scanf. And for now, the only way we've really learned how to interact with this program is through the keyboard and the terminal. So you can see things on the terminal and you can type things on the keyboard. Right? And scanf waits for you to type something on the keyboard and feeds that to the computer program. Okay. That's why we work. No, like, doesn't do it. Okay, I see. So first of all, here, we're doing some provisions. So the final hour, whatever hour is now plus how far I would advance. So let's just stick it out. Get about the minute. So let's say I want to advance exactly 24 hours. Yeah. It's 1 o'clock. Advance for 24 hours without much. It's 1 o'clock, right? So that means if it's 1 o'clock plus 24, this is going to be 25. There's a 25 inside that variable right now. This doesn't matter, that's 0. The final hour equals 25 plus 0 on 24. If we divide 25 by 24, what's the rank? You have 1. So if you print that, what time is it? Oh, sorry. So this is 24 hours. If you want it 12 hours. But it would be a little off because then it would be 0 to 11. So mod is always 0 to 11. So if I had, for example, if that were 24, 24 divided by 24 is 1, 0. So it's like that 0. So if you think about how 24-hour military conflicts, there is no there's 0 of 23, 0 of 23. So that's all we're doing.
Whatever that is, divided by 60, that's how many extra hours. Add those, what am I ordering? That's 300. Then I gotta add all those hours here before I do mine. I'm on. How do you interact with someone else? Just face yourself. How would you interact with yourself? What the only way you can really interact with people on the front. I think it was printing stuff on the screen. So in that context, how would you mask yourself with someone else? But print it on the screen and they see it, it's kind of equivalent to, oh, that's how it happens. If I were right now. And if you wanted to capture their, anyways, how do they interact with you? You're the computer program, how does the person interact with you? Given what we know in this stress. They use type of before that. Scan, save something that's type of into there. There should be examples. What is the person? I'm pretty sure it's put it inside the string. It's an actual character that you're telling print is. You're telling a computer you want to print the return. Otherwise, everything's just going to print on one line. So you tell it to print the All right, there are a few more minutes left. I encourage you to keep working on this on Wednesday, but try not to look at the key. So remember, this is to help you. There's no grade for this. There's no penalty for not doing it, not succeeding. Try your best. On Wednesday, we're gonna kind of do the same thing again, but this time we're gonna try to take some of these instructions and separate them and split them and put them in a separate function. So we can kind of see how functions interact with the computer program that we're writing. And if you all don't have any questions, you're welcome to stick around for a couple more minutes. Otherwise, have a good day, and I'll see you all on Wednesday.